Glass is a material with a high environmental impact, presenting many challenges when it comes to sustainability. To address its environmental impact, we can rethink the way glass is supplied and used. In the waste hierarchy triangle, the rethink or redesign is the strategy with the highest environmental benefit. Following the hierarchy, it is possible to achieve a circular management of glass waste. To rethink how we approach the use of glass, we can focus on two key strategies: rethinking the supply chain of glass and redesigning glass products. Rethinking the supply chain aims to achieve several important goals, including raise the circularity of float glass, and this means increasing the amount of float glass which is recycled, avoid low-value recovery. We should aim to recover glass in application which retains its value, rather than allowing it to be downcycled into less valuable products. Build a repatriation chain to collect the post-consumer glass waste, and this involves creating a system to efficiently collect and return the glass waste to the manufacturing process. Prefer selective deconstruction over building demolition. Selective deconstruction allows us to carefully dismantle buildings to recover materials like glass, rather than demolishing buildings and losing valuable resources. The second approach is redesigning glass products. This can be done by applying several design strategies, such as design for disassembly, to facilitate the separation of material, design for reuse to facilitate the reuse of the materials, design for recycling to facilitate the recycling, and design for repair to facilitate the repair of the component. Let's dive into the first approach: rethink the supply chain of glass products. The aim is to shift from the traditional linear life cycle of glass, where it is manufactured, used, and then discharged, towards a more circular model. The current linear process includes manufacturing, a use in the construction field, a period of service life, and ultimately ending as waste. However, achieving circularity isn't without challenges. In the current scenario of glass, landfill remains the primary end-of-life destination, with downcycling at best for a small portion of glass waste, as container glass and insulation panel such as fiberglass. To rethink the supply chain of glass and make it more circular, there's the need to rethink the processes and the stakeholders involved in them. After their first life cycle, glass products can be repaired to extend their lifespan. Additionally, some glass products can be reused directly or disassembled, and the glass remanufactured into new units. If they can't be reused, they can be treated and recycled by melting the cullet in the manufacturing process. By adopting these strategies, reuse, recycling, and remanufacturing, we create a sustainable supply chain for glass, reducing waste and conserving resources. Now let's dive into the second approach, which is the redesign of the glass products. And here we will focus on the design for disassembly of the insulating glass unit. Here's the scheme of an insulating glass unit. By designing insulating glass unit for disassembly, we should ensure that they can be easily taken apart at the end of their life, allowing each component to be reused or recycled. At present, there are very few examples of facades design focused on the ease of disassembly at the end of life. However, should be noted that assembling of insulating glass unit is currently an optimized and economic process at an industrial scale production, and therefore is unlikely to change in the next future. These are the components of a double glazing unit with a typically metallic frame spacer. The connection diagram shows the various parts of the insulating glass unit and how they are interconnected, especially focusing on the connection type between two different materials. To apply the design for disassembly, we need to rethink these connections. For instance, using reversible adhesive or mechanical fasteners instead of permanent bonding can make disassembly much simpler. Adhesive connections represents the main constraint for glazing disassembling. Therefore, the links 3.1 and 4.1 need to be redesigned. Here there are few examples of attempts to develop the design of an insulating glass unit which is dismountable, and they are mainly developed by students during their thesis project. Beyond these few examples, the research on the topic is not fully investigated at the moment. In this lesson, we explored the Rethink strategy and how this could be applied to reduce the environmental impacts of glass. We focused on two key strategies: rethinking the supply chain of glass, and this involves increasing the circularity of float glass, avoiding low-value recovery, establishing a repatriation chain for the glass waste, and preferring the selective deconstruction over the building demolition. Redesigning the glass products. The design for this assembly approach ensures that the components of a product can be easily separated and repurposed at the end of their life. Although many challenges exist, such as the adhesive connection in the insulating glass units, innovative approaches can facilitate disassembling and recycling, so are worth to be investigated.